All right, let's get into the chemistry of zinc. This is your ultimate exam review, so let's nail it.
So, first up, why is zinc kind of the odd one out in the D block? What's its deal?
And here's the key. Its d orbital is completely full. We're talking a perfect D10 configuration.
And that's why it doesn't act like a typical transition metal. No variable oxidation states here.
Okay, section 1. How do we get pure zinc? Let's trace it from ore to metal. First, we take its main ore, zinc blende, crush it up, and concentrate it with froth flotation. Basically, we use air and pine oil to make the good stuff float away from the junk. Step 2 is roasting. We heat that ore way up to turn the sulfides into an oxide.
This all happens inside a reverberatory furnace, converting zinc sulfide to zinc oxide. Pretty neat. Then, we reduce the zinc oxide with coke at super high heat. That gives us raw liquid zinc.
But that spelter zinc is impure, so for the final step we refine it, usually with electrolysis.
And here's how that works. The pure zinc plates onto the cathode, leaving impurities behind.
Okay, now for the fun part, zinc's key chemical reactions. This is where it gets interesting.
A huge property to know is its amphoteric nature. It reacts with both acids and bases.
But its reaction with nitric acid is really cool. The concentration completely changes the outcome.
With concentrated acid, you get nitrogen dioxide, but use dilute acid and you get laughing gas.
Go with very dilute acid, and it forms ammonium nitrate, a totally different product again.
Next up, a super important compound, zinc sulfate. You might know it as white vitriol.
Making it in the lab is pretty simple. Just react zinc oxide with dilute sulfuric acid. Now watch what happens when you heat it. It loses water in stages, then completely decomposes.
All right, time for a rapid review. Here are the top 5 things you absolutely have to know. Just 5 key concepts. Let's lock these in. You're going to see these on the exam for sure. Number 1, it's not a true transition metal. Why? That full D10 orbital. Simple as that.
Number 2, its amphoteric nature. It plays both sides, reacting with acids and bases. Classic stuff.
Number 3, the nitric acid series. Remember, the acid's concentration dictates the product every single time. Number 4, know the lingo. Spelter zinc is just that impure crude metal before it's refined. And finally, number 5, white vitriol's breakdown. Know how it loses water step by step when heated.
So knowing all this, think about it. How does this unique chemistry make zinc so vital in biology?